Welcome in the online physics class conducted by BPS Convent School, Lachmangarh. Today we want to continue the chapter units and measurements for class 11 physics. Earlier we have studied system of units. We have discussed two unit systems. One was CGS unit system and another one was FPS unit system. Now we are going to discuss MKS unit system and then we'll start the main unit system adopted nowadays, the SI unit system. So today's first topic is third unit system, that is called MKS unit system. M stands for meter, that is the unit for length. K stands for kilogram, that is the unit for mass, and S is the unit of time, second. This unit system is also named as metric unit system because we use always multiple of tens to express the amount of physical quantity. So this unit system is also called metric unit system. Meter, symbol is small m. Meter is the unit of length kilogram symbol is small k, small g. Kilogram is the unit of mass and second symbol is small s is the unit of time here. So this is called MKS or metric unit system, which has three fundamental units. One is meter, another one is kilogram, and the last one is second. Now this MKS unit system is rectified and enhanced, and it is now called SI unit system. Rectified and enhanced MKS unit system is now SI unit system. It has 7 fundamental quantities instead of 3. SI unit system has 7 fundamental quantities, and along with fundamental quantities there are 2 supplementary quantities also. So now we are going to discuss SI unit system, which is used nowadays universally. So it is the system of units used internationally for scientific technical, commercial, and industrial purpose. Nowadays, this system of unit SI is used universally, internationally, hence the name System International, because it is used internationally and it is used in scientific research, technical research, commercial use or industrial use. In all the sectors, this unit system is used nowadays. It contains seven fundamental and 2 supplementary quantities. It contains 7 fundamental and 2 supplementary quantities. Next to it, we are going to tabulate 7 fundamental and 2 supplementary quantities along with their standard symbols. There are standard symbols assigned to each and every fundamental and supplementary quantities in SI. So we are going to name the fundamental quantity, name the unit of it, and give the symbol of this fundamental and supplementary quantity. So we are going to tabulate, make a table to show fundamental and supplementary quantities along with their symbols. So the next topic is fundamental quantities and their symbols in SI. So, first column is serial number, second column is name of fundamental quantity. Its fundamental unit, and its symbol. So, first one is mass. Mass is the first fundamental quantity here, and its fundamental unit name is kilogram. And its symbol is small k, small g. Notice very carefully that it is small k. If you write capital K, small g, then this is not adopted as unit of mass. This is not the symbol of unit of mass. It is actually Kelvin into gram. For kilo means 10 raised to power plus 3, we use always small k. Prefix is small k for 1000. Kilo means 1000. 1000 is called kilo, and that symbol is small k. And if you take 1 kilo of grams means 1000 gram, then it becomes kilogram. So symbol of gram is small g, symbol of kilo is small k. So it is small k small k small g is the symbol of kilogram. If you write capital K small g or capital K capital G or anything else, then these are not the symbols of kilogram. That is the unit of mass in SI. So, its symbol is small k small g. Second fundamental quantity is length.
2 meter. 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 2 meter.
its unit is named as meter, and its symbol is again small m. If you write capital M, then it is incorrect. If you write meter as capital M, then it is incorrect. Capital M means mega. Capital M stands in SI for 10 raised to power plus 6. 10 lakhs is symbolized as capital M. So the symbol for meter is small m. In fact, all the units are symbolized as small case letters except the unit symbols which are in the name of some scientist. If some unit symbol is in the memory of some scientist, say Newton, Joule, Watt, etc., then it is written in capital letters. Otherwise, it is always written in small case letters. Here, if you write capital M for meter, then it is not meter, but it is indicating 10 lakhs, mega. Mega means 10 raised to power plus 6. It is a prefix. Getting it? So the second fundamental quantity is meter. Third fundamental quantity is called time, and its fundamental unit is named as second, SECOND, and its symbol is again in small case letters, and it is simply S. If you write SEC or S or SEC, these are not the symbols for the time unit, second. Time unit second symbol is small s. Remember it very well. Generally it is a practice to write SEC dot, that is not the symbol of time. So be aware that the symbol of time is small s only. It is not SEC or capital S. Capital S is Siemens. It is another derived unit symbol. So it is Siemens. You will learn this symbol in class 12 course when you study electricity. And capital SEC is unknown. It is not the symbol of time. So these are the three fundamental quantities. Fourth one is thermodynamic temperature. Thermodynamic temperature. Its unit name is Kelvin. Kelvin. Kelvin is in the memory of the scientist Kelvin. So it is in the name of a scientist, therefore its unit symbol is written in capital case letters, and it is simply K. Remember again that don't put degrees. Earlier, when degree Celsius or degree Fahrenheit were used, then small circle is attached here and it is called degree. But when using Kelvin, there is no circle over here, means it is written without any degree symbol. So notice that it is in capital K letter, it is simply K without any degree. And when you write this unit in full form, then you will not use capital K. Whenever units are written in full form in a word, then always use small case letters, whether it is in the name of a scientist or not. Here it is in the name of scientist, but we'll write this as small k ELVIN. All letters are in small cases. Getting it? So Kelvin is without degree, its symbol is written as capital K without putting any degree symbol here. Now the fourth one is called fifth one is called fundamental quantity is electric current. Electric current. Its unit name is ampere. You have used this in your class 10 syllabus. Whenever you were writing the magnitude of electric current, then you were putting a symbol capital A that stands for ampere. Since this is a name of scientist, therefore its symbol is again in capital case letters and it is adopted as capital A. Ampere is the symbol for electric current unit. Don't write it as AMP dot. It is not the symbol of electric current. AMP dot is unknown. It is not taken as standard symbol. Standard symbol for electric current is simply uppercase A letter. So A is the symbol for the fundamental quantity electric current. Then next fundamental quantity is named as amount of substance. We'll use this quantity very rarely, but in chemistry, you will use this quantity very, very frequently. And its unit is called mole. MOLE, mole. And its symbol is MOL only. Is discarded, and MOL in small case letter is taken as the symbol for the physical quantity amount of substance unit. And last quantity is for light, and it is called luminous intensity. Luminous intensity. Its unit name is candela and its symbol is CD. We will never use this symbol, this quantity in 11th as well as 12th class syllabus because we don't have any chapter which is related with the measurement of intensity of light in terms of candela. So, we will never use this luminous intensity. We will scarcely use this mole, rarely. We will not use electric current quantity in 11th class syllabus. 11th class syllabus is all about mechanics, thermodynamics, properties of matter, waves, etc. So, we will not use this electrical quantity in class 11 syllabus, but in class 12 syllabus this quantity will be used very frequently. In fact, the volume 1 of NCERT textbook of class 12 is all related about electromagnetics. So, we will use electric current in class 12 and we will use these 4 quantities very frequently in our 11th class syllabus. 4 chapters are devoted to temperature and thermodynamics and heat, etc., in which this Kelvin scale will be used, and all mechanical quantities will use kilogram, meter and second. Whenever quantity is of thermal type, then we will use this Kelvin unit also. So, in 11th class course, we will generally use mass, length and time, MLT, kilogram, meter and second generally, and we will also use this temperature quantity in some of the chapters, and we will not use this electrical quantity. We will use this quantity in class 12. We will scarcely use this amount of substance, means mole unit, rarely, and we will never use this last unit candela because there is none of the chapters which include measurement of intensity of light sources in class 11 or class 12 syllabus. So, these are the list of fundamental quantities, their fundamental unit names and their symbols. This last column is very, very important. So, remember this as it is. Don't mix up these small case letters with capitals or capital case letters with small ones. Adopt these symbols as it is. These are standard symbols. These are not meant to distort in any ways. Getting it? So, this table gives you a preview of fundamental quantities, their units and their symbols. Now, we are going to make another table which will contain the supplementary quantities. So, the heading will be supplementary quantities and their symbols in SI. Supplementary quantities and their symbols in SI. First column is as it is, serial number. Second column is for the name of the supplementary quantities. So, write here the column name as name of supplementary quantity. name of supplementary quantity, then its unit means supplementary unit. So next column is for supplementary unit. So this is for supplementary unit, and last one is for symbols of supplementary quantities, unit symbol. So there are two only. First one is for the measurement of plane angles. Plane angle means two-dimensional angle. Up to class 10th, you have studied these angles only. Whatsoever angle you have framed was lying only inside the plane of the paper. It is not coming outside of the paper. So it is two-dimensional angle you generally used, and there you used degrees for their measurements, 60 degree, 30 degree, etc. But here in SI unit system, degree is not adopted as unit of this plane angle or two-dimensional angle. Its name is radian. Unit name for this plane angle or two-dimensional angle supplementary quantity is radian, and its symbol is RAD. Remember that it is RAD, it is not RED. RED is a color, red color, but it is RAD, stands for radian. Radian is a unit adopted in SI unit system for plane or two-dimensional angles. Getting it? And the second one is for the three-dimensional angle. Number 2, solid angle. That is three-dimensional angle. Now, the angles are coming outside of the paper. Look at any corner of this room, you will see one corner and there is an angle. And that angle do not lie in the plane of this wall or that roof, etc. It is lying in all the three walls, means it is coming out of this wall, it is coming out of that wall, it is coming out of that roof also. So there are angles which comes out of the plane of the paper, and that are three-dimensional angles now, and that solid angles are measured in the unit steradian. Its unit is steradian. and its symbol is small s, small r. SR is the symbol of this three-dimensional or solid angle. It stands for steradian. Getting it? So you have used these angles up to class 10th. Perhaps you have not used this unit, radian. You have generally used degree units. But whenever you have written the angle as pi by 6 or pi by 3 or pi or 2 pi, etc., then unknowingly you are using this unit system, radian. If you use 30 degree and write it as pi by 3 or pi by 6, pi by 6, 30 degree equal to pi by 6, then pi by 6 is in radians. 30 degree. Actually, here placed is C. C for circular measurement. But this pi by 6 is in radian units. It is not in degrees. 2 pi means 360 degrees, but 2 pi were in radians. 2 pi radians equal to 360 degree. Pi by 6 radian means 30 degree. Pi by 3 radians means 60 degree. So this is the unit used for plane angle, and this unit steradian is for solid angle, three-dimensional angle, angles which come outside of the plane of the paper, which are not contained in 2 dimensions but contained in 3 dimensions. If you have tested softy, this is a softy cone in which some ice cream is filled up. If you look at the cone only, then there is an angle. If you look the softy cone only, blank softy cone is available in which through the scoop the vendor fills up some ice cream. If you look at that softy cone, then you find that there is an angle which do not lie in a plane. It lies in space. Likewise, this corner lies in space. It is not in a plane. So these angles are termed as solid angles. We'll use this solid angle concept only in class 12 when you will study Gauss theorem in first, second chapter of class 12 syllabus. We'll study electrostatics, and there comes Gauss theorem, which uses this solid angle concept. Without this concept, you can't prove Gauss theorem. So we will use this solid angle concept only once, and that is when we study Gauss theorem in class 12. Getting it? So these are two supplementary quantities named as plane or two-dimensional angle, which will be used generally. Its SI unit is now radian, and its symbol is RAD. Remember it, it is not RED. And solid angle, three-dimensional angle, angle which are not contained in the plane of paper but contained in the space are three-dimensional angles. Its SI unit is steradian and its symbol is small s, small r. So these are the fundamental and supplementary quantities taken in SI unit system. I have tabulated the quantities along with their unit names, along with their symbols. Special attention is to be given to this symbol column and mug up all the symbols as it is. They are standard symbols. They are not meant to distort in any ways. So, this is the topic for today's lecture. Tomorrow we are going to define all these 7 plus 2 quantities. How SI defined them, you know now very well that units are predetermined and well defined. So how well defined these units are, we will study tomorrow. Thank you very much. We will meet soon.